Alright, how's everybody doing out there in calculus land? Today, this is Mr. Muscarella coming at you with an example of the mean value theorem for integrals. Now, a lot of times you'll be presented with a problem like this. It'll say, find the value of c guaranteed by the mean value theorem for integrals for the function over the given interval. So we've got our function f of x equals 2 secant squared x from negative pi over 4 to pi over 4, that closed interval. So one of the things that we're going to do is we've got to first say that the function f of x is continuous on that closed interval. Now, since it is continuous, then by the mean value theorem for integrals, the integral of from a to b of f of x dx is going to equal f of c times the quantity b minus a. And b and a, they are going to come from these values right up here in your closed interval. Those are going to serve as your values for b and a. Now, as you go through this, what you're going to do first, we're going to kind of break this up into two pieces. We're going to break it up into a piece on the left, working with just the integral part, and then we're going to break it up into a piece on the right side of our equation. Now, one of the things you want to do is work with each piece kind of one at a time. So what I'm going to do first is work with the integral piece on the left. When we do that, we're just going to plug in our limits of integration from negative pi over 4 to pi over 4, and then our function is going to be 2 secant squared x dx. When we integrate that, the integration ends up being 2 tangent x, and again our limits of integration go from pi over 4 to negative pi over 4, and then all we have to do is evaluate that. What I'm going to do is just pull out the 2, since that's a constant. So that way I'll just evaluate tangent of pi over 4 minus tangent of negative pi over 4. When I do that, I get 2 times the quantity of 1 minus negative 1, which of course we can do our arithmetic, and we know that that would give us a value of 4. So that's the left side. That's the left side right there. Now on the right side, for that f of c times b minus a, what I'm going to do is plug in c for x in my original function f of x equals 2 secant squared x. So that's going to give me 2 secant squared c. And then b minus a, of course, are going to be pi over 4 minus negative pi over 4. When I clean that up and do my arithmetic, I'll end up with pi times secant squared of c. Now when I do the arithmetic, again, I'm just working with one piece at a time. So I'll end up with, when I'm done working with both the left side and the right side, you end up with 4 equals pi times secant squared of c. Now the next thing that we're going to do is we're just going to solve this for secant squared of c. But wait, we've got to do a little bit more. Next, we'll go ahead and take plus or minus the square root of both sides, so that way we'll isolate the secant of c. Don't forget the plus or minus. Now some textbooks will actually have you go this way with it, where they'll simplify the square root of 4 in the numerator to come up with just 2. The denominator, just leave that as square root of pi. This is where it's going to get interesting, because to solve for c, you are going to have to use inverse trig. So let's talk a little bit about the inverse trig. When you do that, to find the value of c, you'll use plus or minus, don't forget that piece, of arc secant of 2 over square root of pi. You could also rewrite that as c equals plus or minus arc cosine of square root of pi over 2. Remember, you have to flip your angle if you're going to use a reciprocal function of secant, which is cosine. Depending on your graphing calculator, if you have a CAS, you may be able to type in arc secant. If not, you can go ahead and use arc cosine, but there's two things you have to remember. One, you've got to be in radian mode. So don't forget to make sure your calculator's in the right mode. The next thing you do, when you type it in, just take your time and make sure you put it in correctly. So the value of c, guaranteed by the mean value theorem for this particular problem, is c is approximately plus or minus 0.4817. So that's a quick example of how to find a value of c guaranteed by the mean value theorem for integrals. Thanks for watching, and you guys have a great day. Peace out.